And your Yiddish word of today is Mazel Tov. And Mazel Tov is just a phrase for means congratulations. Anything that's celebratory. If someone did something great, you say, hey, Mazel Tov. You probably heard me use it in class 1,000 times. So your Yiddish word, Mazel Tov. So I'm going to go a little deeper into lesson 5.5 that starts on page 196 and still dealing with direct variation. And the thing is that we have to learn how to show direct variation in all different situations. So you can add this to your learning log if you wish. If you don't, that's okay too. But if you want to, you can write down the examples I'm about to do in your learning log. But I want to go through the graph in 4 different situations so that you can answer the questions in the book and on IXL. So look at this first situation. We have a coordinate grid, and then we have a line that's straight that goes through the origin, 0.00. This is, yes, this is a direct variation because it's a straight line and it goes through 0, 0. But let's look at this one. Is this a direct variation? The answer would be no. Yes, it's a straight line, but look, it doesn't go through 0, 0, the origin. It has to have both. It has to be a straight line and it has to go through 0, 0. So this answer would be no. That's not a direct variation. What about this one? Well, it goes through 0, 0, but can you tell what's wrong with it? Well, it's a curve. And curves are not direct variations. So this is also a no. It has to be a straight line and go through 0, 0. You may look at this one and say, well, that's a straight line and it goes through 0, 0, but it's pointing in the wrong direction. Instead of going up, like in this one, you read it from left to right, it's going up. In this one, read it from left to right, it's going down. But yes, it is still a direct variation. Why? Because it's still a straight line and it goes through 0, 0. So the answer here is yes. This is a direct variation. There's also a little special bit of information I want to give you. This situation here, see how the line goes up? We read it from left to right, the line goes up. We call this has a positive slope. This one over here, it's a straight line, goes through 0, 0, and it's decreasing. As we go from left to right, the line is going down. So we say that this has a negative slope. Now let me change this and go to the next page. Okay, so here we have 6 more examples. And it's just calling it example 2. It's just 6 little equations over here. And we have to know how to find direct variation in an equation as well. So I'm going to go through all these 6 really quickly so that you can see which ones are direct variations and which ones aren't direct variations. So in this first example, if you remember from our last video, a direct variation in an equation has to just be a value, some number, multiplied by x or divided. It's okay if you divide. So here we have a number multiplied by x. And even though it's a negative number, it's still okay. This is a direct variation because we have some value. Doesn't matter if it's positive, negative. It just matters that it's some sort of value multiplied by x. So yes, this is a direct variation. This one too is a direct variation. Why? Because we're just dividing by 4, which means multiply by 1/4. But we can divide by a value to have a direct variation. So this is also a yes. This one here, if you notice, it's 4x. Do you remember what these are? These are called exponents. This is 4x cubed, or 4x to the 3rd power, to the power of 3. When we have things that have powers like this, any power greater than 1, or less than 1 for that matter, then it's not a direct variation. So this is a no. This is not a direct variation. Why? Because it has a power. What about this one? 4/5 x. Well, this is also okay. This is a yes because we have some value multiplied by x. So this is a yes. Doesn't matter if that value is a fraction. That's okay. Let's look at this next one. Oh, what do we have here? One with an exponent again. So this is a no. And this last one, you may think that, oh yeah, it's got, we're dividing, but it's not dividing by a value. It's dividing by a variable. And we can't do that with direct variation. It doesn't work because that variable could be a 0 and we can't divide by 0. So no, this is not a direct variation. Anytime it's a direct variation, we would have something that is multiplied by x, whether it be 5x, 2x, or a fraction, decimal, it's perfectly fine. Even if you saw something like this, a decimal. It's perfectly fine. This is a direct variation. Now let me go to the last example. Okay, so we're back and we're going to look at tables. And I want you to look at these tables and we're going to do something to them to figure out their direct variations. And there's a very, very easy way to tell. And actually you'll need, or most probably will use a calculator when doing this. So what we're going to do is we're going to go ahead and we're going to divide these. But you don't divide the 0, 0, 1. So like the 0, 0, 1, because 0 divided by 0 is just 0. So actually you can't divide by 0, so don't worry about that. But just don't worry about the 0 ones in this case. You only look at the number cases like 20, 40, 60. And we're going to divide those. So you do 20 divided by 1, 40 divided by 2, 60 divided by 3. If you do all those, you'll get 20. Now remember, when you put it in the calculator, when you divide 20 divided by 1, you hit 20 divided by 1. Don't do this. Don't do 1 divided by 20. That would be backwards. You're going to go ahead and you're going to do 20 divided by 1. And then you get your answer. So you'll get 20 each time. 40 divided by 2. And 60 divided by 3. See how I got 20 for all of these? I divided all of these and I got 20 for each one. That means this would be a direct variation. But hold on. What if the last one were this? 40 divided by 4. Well, that would be 10. Thus, this would not be a direct variation. Why? Because this last one here, and if any one of them doesn't work, then the whole thing is not a direct variation. Well, this one, 40 divided by 4 is 10, so it's not a direct variation. Let's take a look at this one. Negative 8 divided by negative 2. Negative 4 divided by negative 1. Do we divide this one? Nope, we skip the 0, 0, 1. 4 divided by 1, 8 divided by 2. We'll divide all those. I'll give you a moment. Did you get the same number each time? If you did, then you got it correct. You should get a 4 every single time. So this is a yes. This is a direct variation. But let's look at this last one. 1 divided by negative 2. Well, that would be negative 2 if we did that. What about 2 divided by negative 1? Well, that would be negative 2. What about 4 divided by 1? Well, that would be 4. 5 divided by 2, that would be 2.5. You see how you got different values each time? So this is a no. This is not a direct variation. So to see it in a table, a direct variation in a table, just make sure you divide the y by the x, the y by the x. And this number that you're getting every single time when you divide the y by the x, we call this the slope, or what's also called the fancy constant of proportionality. Now do the attachment and submit your work. Thank you very much.